All right, today we start the new chapter. So the last chapter on conic sections, you know how intense the algebra was. So you have to be good at algebra. In this chapter, you have to be good at arithmetic. In other words, addition, subtraction, multiplication. Oh, there'll be no division. So this is a pretty short chapter. I believe there's only 4 homework assignments for this. So, what is a matrix? Well, I put the notes up there. A matrix, did you guys learn matrices last year? What? What about in pre-algebra? Because this stuff is on the ACT. I have yet to see it on the SAT, but ACT is definitely there. In fact, if you were in my summer school class, then we did it, right? Didn't I teach you guys how to multiply? But you guys probably forgot, yeah? All right, so a matrix is a rectangular array of numbers. So for example, like this, 2, 3, 5, 4, 2, 1. It's a rectangular array of numbers, and we put it in these brackets like this. We usually denote a matrix with a capital letter like this. So if somebody were to ask you, what are the dimensions of this matrix, what will you say? It is 2 by 3. What's wrong with this thing? It's 2 by 3 because it has 2 rows and 3 columns. The rows go across like this, and the columns are up and down like the columns of a building, yeah? You always give the number of rows first and then the number of columns second. And then capital letters are used to denote the matrix, and we use lowercase letters to denote the elements in that matrix. So, for example, what is A12? In other words, what element is in the first row and the second column? Yeah, well, Mr. Park, how do I know which one is the first row? Well, everything is dependent upon the upper left-hand corner. This is the first row, and this is the first column. Okay, so what element is in the first row but the second column? 3, right there. First row, second column. What is A23? What element is in the second row, third column? 1. So capital letters for the matrix itself, lowercase letters for the elements of the matrix. Okay, so today we're going to go over the basic operations of matrices. So first one is, how do you multiply a matrix by a constant? Well, that's easy. If this is matrix A, what do you think 3 times matrix A is? I mean, if you just have to guess. Yeah, you just simply multiply every element by 3. So you would get 8, 9, 18, 12, 6, 3. See, this is why you can learn it actually in pre-algebra, because it's very simple, but it can do really powerful things. Okay, next, what about adding matrices? Well, the only way you can add matrices is if they have the same dimensions. So if A is 2 by 3, you can only add it to another matrix that's 2 by 3. So for example, if matrix B is also 2 by 3, then what kind of number shall we put in? How about 6, 5, 2, 4, 1, 7. How do you add matrix A plus matrix B? You can probably guess and figure it out. You simply add the corresponding element. So 2 plus 6. Really? 8. 3 plus 5. 8. 5 plus 2. 7. 4 plus 4. 8. 2 plus 1, 3, 1 plus 7, 8. That's how you add matrices. It's very, very simple. What about subtracting? Well, subtracting is defined to be, A minus B, is actually defined to be A plus negative B. And you know how to multiply B by negative 1, and you simply add it to A. But you can actually just subtract the corresponding elements as well. So if you you go 2 minus 6. See how you gotta know arithmetic here? 3 minus 5. 5 minus 2. 4 minus 4. 2 minus 1. And 1 minus 7. So that's how you add and subtract and multiply by a constant. Easy, right? Now I'm going to tell you this. This chapter is not that easy now. But it is the easiest chapter this quarter. So if you want to raise your average, this is the chapter to do it on. Because the two that come after this, they're quite intense. All right, now what about multiplication? Do you think, like if I said multiply A times B, you can just simply multiply the corresponding elements? Well, you wish you could, but you can't. So if you were in my summer school, I forget who was in my summer school class already. Do you guys even remember how to multiply matrices? Like, could you multiply A times B? Okay, well, read the definition of multiplication right here. To multiply matrices A and B, if matrix A is m by n and matrix B is n by p, then matrix C, which is the product of A and B, is m by p, and this is how you find the corresponding elements. So the next thing that I'm going to ask you, did you guys use this notation last year, or do we have to just learn it right now? You ever seen this sigma before? Well, you're in AP Stats, so you did, right?
No.
Huh?
No.
Yes?
No.
Okay. Anybody else know the sigma notation? Okay, so let me teach it to you then. Doesn't look like we know. If you have sigma, n equal 1 to 5, say, n squared. Now this is the Greek letter sigma, which is the capital. This is the capital version. The lowercase version of sigma looks like this. We use that in statistics for
Standard deviation.
standard deviation. But if you use the capital sigma, we use that for summations. Okay, so basically this tells you the starting value of n. This is the ending value of n. And you keep on increasing it by 1 every time by plugging it into this formula. So if you start by plugging in 1 into this formula, what do you get? 1 squared. 1. Then you plug in the next integer, 2. 2 squared. 3 squared. 4 squared. 5 squared. When do I stop? When you get to this number here. So it's very important, you gotta look at this and this now. This is where you start, this is where you end. And sigma is the Greek letter for S, which stands for sum. So what we're going to do is we're going to sum these. We're going to add them up. That's how sigma notation works. So you really never saw this before. Well, good thing we're learning it now. And then we're going to learn it again in the fourth quarter. We're going to do some heavy-duty stuff there. So, okay, let's keep A and B up here for now. Because if you can't do this, then you can't multiply matrices. So, okay, so after reading that thing, can you multiply A times B here? Because pretty much all of tonight's homework is just multiplying matrices, because if you cannot multiply matrices, you're going to fail this chapter. It's that simple. Can I multiply A times B? Why not?
Good.
Well, first of all, what are the dimensions of matrix A? 3 by 2. What are the dimensions of matrix B? 3 by 2. So if you read that thing, it says matrix A is m by n. Matrix B has to be n by p. In other words, these two have to be the same. Well, are these two numbers the same? No. If these two numbers are not the same, then you cannot multiply them. So this would be undefined. You wouldn't be able to multiply it. And you will see why when I actually show you how to do it. So that means we need to change matrix B. So if matrix A is 3 by 2, we need matrix B to be 2 by something. So let's change it. Okay, so let's make it 3 by 2. Wait, this is not 2 by 3. It's 3 by 2. It's 2 by 3. 2 by, same thing. These two numbers are not the same. My goodness, I'm losing it here. So So 2 by 3, so we need matrix B to be 3 by something. So it's gonna look like this, I guess. Okay, let me think of some numbers. 4, 1, 2, 5, 3, 2. Okay, now can I multiply them? Yes, because matrix A is 2 by 3, matrix B is 3 by 2. If these two numbers are the same, that means you can multiply them. And what is the resulting matrix going to be? That's why you gotta read, people. Okay, look. If matrix A is M by N, matrix B is N by P, matrix C, which is the product of the two, is M by P. Well, here's M and here's P. You look at these two outside numbers. So if I multiply A times B, you're going to get a matrix that is 2 by 2. A times B, it's 2 by 2. You know what? I'm going to make it bigger like this. And if it's 2 by 2, it has 4 elements in it. Now, how do I figure out these 4 elements? You have to use that formula right there. Okay, so what does it say? C sub ij, so matrix C is A times B, is equal to sigma, what does it say? I can't even read. K equal 1 to n, A sub, what does it say? Ik, B sub kj. That's how you figure out each element. Now some of you are going, what the heck is going on? Well, it's just somebody defines something and then you gotta figure out how it works. Okay, so let's say you wanna figure out this element right here. What is the row and column number of this element here? 1, 1. It's in the first row and the first column, right? Okay, so what I wanna do is I need to compute C11. So this is kinda like a function. So what do you think I'm going to plug in for I and j? 1 and 1. So wherever I see an I, I'm going to plug in 1. Wherever I see a j, I'm going to plug in 1. Okay, so here we go. Sigma k equal 1 to n. What is n in our problem? N was this number here, right? It's 3. So k equal 1 to 3. A sub, now what do I plug in for I again? 1. And then what do I plug in for j? 1. Okay, now this still looks strange to a lot of you, but we just learned how sigma notation works, right? So what's the first number I plug in for k? 1. What's the second number I plug in for k? 2. What's the last number I plug in for k? 3. And then what does sigma tell you to do? Add them up. So just do what it says. Okay, so here's the formula. Plug in 1 for k. Do it. A11, B11. Okay, the next number I'm going to plug in for k is 2. Plug in 2 for k. A12, B21. And then finally, this is the last number you plug in for k, 3. Plug it in. A13, B31. And the sigma tells you to add them up. That's how you're going to figure out this element right here. Okay, let's see if we can do it. What is A11? So here's matrix A. What is A11? What element is in the first row, first column? 2. What is B11? Wait, let me put these parentheses here first. That'll save time. What is B11? Well, here's matrix B. What element is in the first row, first column? 4. What is A12? First row, second column. The 3 right there. What is B21? So here's matrix B. What element is in the second row but the first column? 2. What is A13? Here's matrix A. What element is in the first row but third column? 5. And what is B31? Here's matrix B. What element is in the third row, first column? 3. Multiply these numbers. So what is that? 8 plus 6 plus 15. And then do your arithmetic. 29. That's what number you put there. So we have to do all that work just to get that number there. Oh my goodness, Mr. Park, I want to go home. Okay, yeah, so this is the mathematical way to explain how it's done, but when you actually do it, you're not going to do this. This is craziness, right? How many of you program computers? I keep asking you guys this. Anybody? Nobody? You can program computers?
I'm taking computer science.
Oh, like right now?
Yeah.
Oh, so do you guys do 4 next loops? Like when you program like for I equal 1 to 3? Yeah, and then, so it's like, this is like a loop, except you got 2 of them. So that's how you, like, if you have to program a computer to do this, that's what you would have to do. Okay, so, but just look what we did. A11 times B11. Wasn't that this times this? What was the next one? A12 times B21. That's this times this. And then we went this times this. So what actually happened? In the first matrix, the one on the left, you go across the row. The second matrix, you come down the column, like this. So, dunk, 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 and you multiply those elements. See? 8 plus 6 plus 15. So if we do that, how do you think I would get this one? Well, what is the subscript for this one? It's in the first row, but the second column. So that tells you that in the left matrix, I'm going to go across the first row, but in the second matrix, I'm going to come down the second column. So I'm going to go across the first row on this one, but now I'm going to come down the second column. And then you multiply the corresponding elements. So here, 2 times 1, 2. 3 times 5, 15. 5 times 2, 10. Now add them up. 27. That's how you multiply. That's actually what you're doing when you do this. Okay, so you really need the subscript here. That's the key to multiplying. Okay, what? This is 2, 1. It's in the second row, first column. So that tells you I'm going to go across the second row, and then I'm going to come down the first column. Okay, let's see if we can do it. 16, 4, 3, add them up, 23. And then finally, to compute this element, that's 2, 2. That means I'm going to go across the second row, come down the second column. Okay, let's see if we can do it in our head now. 4, 10, and 2. See? You practice after a while, you can do it easily, because it's just arithmetic. But you got to know which ones to multiply. So that's how you multiply A times B. Okay, I'm going to get rid of this thing now. So now, how do you multiply B times A? Shouldn't it be the same thing? Is A times B the same thing as B times A? A times B is the same thing as B times A? Well, maybe. Well, when you work with numbers, it is. 2 times 3 equals 3 times 2. But when you do matrices, are they going to be the same? Well, matrix A is 2 by 3, matrix B is 3 by 2. So when you multiply matrix B times A, B is what? 3 by 2. A is 2 by 3. These numbers are the same, so yes, you can multiply them, but what is the resulting matrix going to be? It's going to be 3 by 3. You look at the 2 outside numbers. So it's going to be 3 by 3, which means it has 9 elements in it. Like this. So do you think A times B equals B times A? No, it's not. So this is one of the most important things with matrices. The commutative property of multiplication does not work in general. So in general, A times B is not equal to B times A. This is one of the most important things. Now there are a few cases where it does work, and you're going to kind of discover it when you do the homework tonight. But in general, this doesn't work. In fact, if you do this on the test or a quiz, this is what we call a fatal error. Every year, students say they understand it, but you cannot, in other words, you cannot switch the order. If you switch the order of the matrices, it changes it. Okay, so how do you multiply b times a? Now for me, what I like to do is I always like to put the left one on the left and the right one on the right. That's what I do. But it's up to you. You can do whatever you want. Some people are good. You don't even have to do this. So I'll do the first one and then I'm going to call on you guys to see if you can do it. Okay, here. What is the subscript for this one? 1, 1, because it's in the first row, first column. But again, those numbers are important because that tells you on the left one, I'm always going to go across the first row. On the right one, I'm coming down the first column. So the one on the left, you're always going across the rows. The one on the right, you're always coming down the columns. And that is why these two numbers got to be the same. Otherwise, you're not going to have the same amount, right? And then you can't multiply it. So you just go like this. 8 plus 4, 12. Okay, who's got this one? Again.
14.
I didn't hear that.
14.
Oh, that's correct. Everybody got that? So go across the first row, come down the second column now. 12 plus 2, 14. Okay, Chad, you got this one. 21 is correct. Everybody got it? So go across the first row, come down the third column. First row, come down the third column. 20 plus 1, 21. That's why we gotta practice. Okay, who's got this one? This is not 2, 1. It is 2, 1. I just wrote it wrong. Okay, Cruz, you got that one.
24.
24 is correct. Okay, 2, 2. Who's got 2, 2? We'll go on this side. Tanaka.
16.
Correct. 2, 3. Wang. Gina. Second column. So if you need to do this, draw this. I mean, second row and then third column like this. Ding, ding, ding.
6.
Well, 5 times 2,
Oh, 10.
and then 5 times 1,
Oh, so 15.
15. This just takes practice. Okay, who's got 3, 1? Kai Wang.
14.
Yep. 3, 2. Liu. 3, 2. Three times 3 is what? Okay, then go across and then come down. Okay, 9 plus 4, 13. See, that's why you gotta be good at arithmetic. Okay, and then finally 3, 3, Kuzumoto.
17.
17 is correct. That's how you multiply matrices. In fact, so again, if you were in my summer school class for SAT prep, because ACT, they actually had problems where you had to multiply matrices. So we actually learned that, but I'm sure it was purged. Anyway, if you guys have that, you guys have access to the SAT cheat sheet, right? It's in there. That's okay, this is just probably better. Okay, I think it seems like we need to do more practice. So that's basically all I'm going to teach you today. We just do basic operations. So what did we learn how to do? Multiply by a constant, addition, subtraction, which are super easy, and multiplication, which is not that easy. That's why we got to practice. What about division, Mr. Park? Well, division is undefined in matrices. There is no such thing as matrix division. Now, you guys are nodding, okay, but every year, I give problems like this on the first quiz. Solve for x. And then students do this. Oh, just divide both sides by a. That's a fatal error. There's no such thing as division. You cannot divide. There's no division. Well, so how do you solve for x? Well, we're going to learn something. I'll teach you that tomorrow. So in the meantime, let's practice multiplying. How do you multiply this? Let's make it a 3 by 3. 3, 2, 1, 4, 1, 2, 1, 2, 3. Now we're going to multiply that by ding and a ding. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay. First of all, can I multiply these matrices?
Yeah.
Well, this is 3 by 3. And what is this? 3 by 4. So this number is the same as that number. So yes, I can multiply it. What is the resulting matrix going to be? 3 by 4. You look at the two outside numbers. So 3 by 4, which means you're going to have 12 elements in it. Okay, so we're going to practice our mental math. Okay, I'll do the first one. So 1, 1. So go, remember, the one on the left, you always go across the row. The one on the right, you always come down the column. So then you just got to go in your head. 3 plus 4 plus 3, that's 10. Okay, so 1, 2, Devere, Graham, wrong period. Graham, 1, 2. Yup. 1, 3, Eva.
13.
9 plus 2, you're right. Oh, you guys getting good. Kimura, 1, 4.
10.
Yep. Oh, I'm getting slow, man. 2, 1, that's what happens when you get old. Cruz, did you have a turn? Yeah, you're going again. Cruz, 2, 1. Oh, I had it, and then I forgot. 4 plus 2 plus 6.
11.
4 plus 2 plus
12.
6.
Oh.
Okay, well. 2, 2, moon.
Oh, no,
Yeah, no,
13.
13 is correct. 2, 3, Liu. Good. 2, 4. Who's got 2, 4? Again. Yeah. Calabrese Kenny. 3, 1.
14.
Yep. 14. 3, 2. Is everybody? Lucky. 3, 2. 2
11.
plus 6 plus 3. Yeah. 3, 3. Lucky again. Oh, you didn't expect that one, huh?
11.
Yep. 3, 4. Tanaka.
14.
14. There you go. Hey, I'm pretty confident of your multiplication skills there. Now, the next thing you gotta know is you gotta be able to do this on a calculator, because your calculator can do all these matrix operations. Okay, let's not do this one. Let's just do this one. Okay, so now I give you calculator instructions in the notes, but there is another way to do it. It might be a little faster. So if you scroll down here, whoa. Hey, wait a minute, you know what? I might have to teach you matrix algebra before we go on. Hey, let me look. Okay, here, matrix operations using a graphing calculator. So if you have a TI, follow this. If you have a Casio, do this. If you have a, what do you call the one you have? HP prime, then you do this. Okay, but there is another way. So what you do is you enter it in a matrix like this, but it might be easier if you just use the template. What you talking about, template? Okay, so here's your calculator. Okay, let me expand this so it's a little bit bigger. Does it get wider? No, not really. Okay, so let's do that problem on the board there. So you got to do the left one first. So you guys know where the template button is right here? The units button here, to the right of the toolbox. Okay, template button, and you see this? You see this matrix right here? Click that one. Now it looks like it's only 2 by 2, but when you click this plus thing here, it expands it. So the first matrix on the left, you got 3, then go to the next one, 2, and then if you want to expand it, you just click on that and then punch in 1. See how it expands? And then fill in the numbers. The hard part is you got to fill in the numbers. Next row would be 4, 1, 2. And then click this and it'll expand it to, and we need 1, 2, 3. 1. I wonder if you could just press enter. No, you can't. Oh, how do you get out of this error? Where's the escape button? There. 1, 2, 3. Okay, then you click out of it, and then you put times, and then you punch in the next matrix. So you do the same thing. Go to the template button, select the upper right-hand corner, and then just input the numbers. 1. I wonder if you can use the right arrow. Would that do it? No? Oh yeah, it did. Right arrow works. 1, 2, 3, 1. And again, the hard part is inputting it. 2, 3, 1, 2. 2, 3, 1, 2. And I'm guessing it's 3. 1, 2, 3. Then right click out of it and then press enter, and then the thing multiplies it for you. So basically in this chapter, you have to become the calculator. You have to become the calculator. All right? And if you want to add them, you put a plus sign in between, but you wouldn't be able to add because they're not the same dimensions, yeah? But let me just check something because I might have to teach something more to you. Oh, I've got a lot of notes in this chapter. Whoa, what the heck? We're on page 11 already. There's 11 pages of notes. Whoa. Oh, yes, I have to teach you matrix algebra. No, but Mr. Park, I already know algebra. Yeah, but matrix algebra is different because the commutative property of multiplication doesn't work. Okay, so I'm going to show you something. There is something very different about this matrix right here. Okay? Or if it's a 3 by 3 matrix, it looks like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. So basically, from the upper left-hand corner, if these are all 1s, and you have zeros everywhere else, this is a very special matrix. So same thing here, see how you have ones starting from in this diagonal, we call this the main diagonal, and zeros everywhere else. It's special. Why is it special? Wait. Because when you multiply this by something, how about multiply this by 2, 3, 5, 7? First of all, can you multiply them?
Yes.
2 by 2 multiplied by 2 by 2. Yep, these two numbers are the same, so the answer is going to be 2 by 2. Well, that makes sense. So how do I get this element here? So after a while, you don't even have to write the 1, 1, right? You know, I'm going to go across the first row, come down the first column. No. 2 plus 0.
2.
Okay, then the next one is 1, 2, so 1, 2. So 0 plus 3.
3.
5 plus 0. 0 plus 7. What was special about it? Yeah, you get, so when you multiply a matrix by this, you get itself. So this matrix here acts like the number 1, but it is not the number 1. There's no such thing as a 1 matrix. Okay? And then what about this? What if you were to commute it like this? Mr. Park, you said the commutative property doesn't hold in general. Yes, but there are certain cases where it does hold. Well, let's try this. So what if you were to switch them? 2 plus 0. 3 plus 0. 0 plus 5. 0 plus 7. Hey, it worked. How come this, so this is one of the special cases where the commutative property does work. Okay, so now, so what's so special about this matrix? Well, it acts like the number 1, but it is not the number 1. There's no such thing as a 1 matrix, okay? So what we do is we call this matrix I, the identity matrix. So with multiplication, it acts like the number 1s. For example, okay, if you have a number 3, what do I need to multiply it to get 1? No, sorry about that. What do I need to multiply it by to get itself? 1. And what do we call this? This is called the multiplicative identity. So when you work with numbers, 1 is the multiplicative identity element. That's why we call this the identity matrix, I. So when you multiply a matrix times I, and you can see from here, this is a special case where the commutative property of multiplication works, you get itself. It acts like the number 1. It is not the number 1 though. So every year, okay, I'm going to tell you right now, do not do this on the first quiz. Every single year, people put like, I don't know, like the 1, you put 1 there. There is no such thing as 1. It's I. And then every year they say, Mr. Park, that's how I write my I. Yeah, and this is how I write -5. Okay? There is no such thing as the 1 matrix. Okay, so now that we know this, now I can teach you matrix algebra. Let's start off with the easiest case. A times x equal b. How do you solve for matrix x? Can I divide by both sides by a? No, I told you, because there's no such thing as division. Oh, wait, I gotta teach you one more thing. Oh my gosh, I can't believe it. Okay, you know what? Wow, this is gonna be slower than I thought. Okay, so I gotta teach you something. Okay, on tonight's homework, I'm gonna ask you, okay, here's matrix A. What do I need to multiply this by so that you can get I, which is 1, 0, 0, 1? What would I put here to get this? How do you figure this out? Okay, well, let me show you. Well, I don't know what this matrix is. I'm just going to put A, B, C, D then. Okay, so how do I multiply matrices? Go across and come down. So 2A plus 3C. Go across and come down. 2B plus 3D. Okay, keep on going. 5A plus 7C. 5B plus 7D. And that has to equal 1, 0, 0, 1. So using common sense, What do you think? How would you solve this? 2a plus 3c has to equal 1. This thing gotta equal that thing. Corresponding elements gotta be equal. 2b plus 3d gotta equal 0. 5a plus 7c is equal to 0. 5b plus 7d is equal to 1. And then you solve these equations. And that's how you figure out what this is. So you're gonna do this in tonight's homework, okay? This is called the ABCD method. So yeah, you gotta be, I guess you gotta do some algebra. Okay, but let me just tell you, so if you were to solve this, okay, wait, let's see if I can do this in my head. Well, you do, so anyone, so you second 2, so negative 7, negative 2. What did I just say? Negative. Five and 3. Let me see if that's gonna work. That don't work. Okay, see, I couldn't do it in my head. Doggone it, that's what happens when you get old. Okay, you know what, let's just solve these equations. Quickly, go. How would you solve these equations? No, you know what, wait, too bad, I'm just gonna do it, I'm gonna attempt to do this in my head. 1, we're not gonna do anything until I do it in my head. I got 1. Yeah, I think it's negative 7, negative 2. Three and 5. Okay, let's see. Okay, yeah. Okay. Woo! I got it finally. Okay, so this is the, okay, so if you were to solve this, you would get that. Okay, what do we call that matrix? If you take any matrix and multiply it by something to get I, what do you think we call this? So here, like if you have the number 3, what do I multiply it by to get the number 1? 1/3. Okay, reciprocal is the street name, yeah? That's the nickname. What is the real name of this? This is called the multiplicative inverse. So this matrix here, since it comes out to this, is called the inverse of matrix A, and we write it like that, A inverse. Now that does not mean 1 over A. It means the inverse of matrix A. Okay, and here is another case where the commutative property works, so let me write that down. A times A inverse is equal to A inverse times A, and you get I. So these are the only 2 cases where the commutative property works now. In all other cases, it's not going to work. Okay, now I can finally teach you matrix algebra. Okay, here we go. A times X equal B. So we know you cannot divide by A, so what do? Well, you can multiply both sides by the same thing. So if I want to get rid of this A, see here, I need an A inverse next to it, right? So what I'm going to do is I'm going to multiply A inverse on the left, like this. But here's the thing. Since the commutative property of multiplication doesn't work, if you multiply it on the left here, you have to multiply it on the left there. See, because when you do regular algebra, like 3x equals 2, you multiply both sides by 1/3, right? And that you can do because the commutative property works. But with matrices, it doesn't work. So if you multiply A inverse on the left here, but you multiply it on the right there, you know what we call this? Fatal error. Because you cannot do that. So if you multiply it on the left, you have to multiply it on the left. That's because the commutative property doesn't work. This thing right here. Okay, everybody understand that? Now, one thing that does work is the associative property. Remember what the associative property is? You can group it like this. See, the thing with matrices is, as long as you keep them in the same order, you're good. But once you switch the order, that's bad. So that means I can do this. And what did we just learn? A inverse times A is what? I. This is equal to I. And what is I times anything?
Anything.
Right here, this one here, it's equal to itself. And that's how you solve for matrix X. Now, after you get good at this, you can just go from here to here. You don't even have to show this. I'm just showing this to you so that you understand what's happening. So you can see here, okay, if I want to get rid of this A, I multiply by A inverse on the left. Boom! Okay, so let's do more complicated problems. This is like when you first started learning algebra and whenever you took algebra 1. Okay, how about this? AX plus B equals CX plus D. Now you got variables on both sides. Okay, so if you want to solve for matrix X, put all the X's on one side. Okay, is that legal? Can I add and subtract the same thing to both sides? Okay, yes, that's legal. Now, if I want to solve for X, what can I do here? What happens if you have an X in both of them? We can factor it out. Okay, so watch what I do. Can I do this?
No.
No, that would be a fatal error. Now, some of you are going, what? And again, the commutative property doesn't work. See how the X is on the right for both of them? So that means you have to factor it out on the right because the commutative property doesn't hold. Are you guys following this?
Yeah.
Okay, how do I get rid of this A minus C? Divide both sides by A minus C? No, there's no such thing as division. So to get rid of this, you have to multiply both sides by A minus C inverse on the left. So without actually showing it, what's the answer going to be? A minus C inverse times D minus B, and please put parentheses. So again, if you multiply something on the left on this side, you have to multiply it on the left on that side. And same thing, if it's on the right, you're going to do it on the right. So, after that I told you that, what if you had this? How do I factor out the X?
You can't.
You cannot factor out the X in this problem. Because it's on the right on this side and it's on the left on this one. So this one, you cannot factor out the X. So the only way you could do this problem is by using the ABCD method. Save that one for the test, yeah. Okay. So does everybody understand this thing about the commutative property doesn't work? Okay, one more and then good enough. How about AX plus X? No. AX plus B is equal to X plus C. Okay, put all the X's on one side. It doesn't matter. Put everything else on the other. Is that legal?
Yeah.
Yep. Okay, now. Well, you know what? Let me change this. Let's change this to XA. Okay, now what? How do I factor out the X? How do I factor out the X? Okay, look, isn't X the same thing as XI? Remember this thing? Okay, so notice that the X's are on the left. So if I factor out the X, what's going to be left? A minus I. And again, there's no such thing as 1 now. You write 1, that's going to be